Alright guys, welcome back. In this video we're going to look at positive externalities as well as what government policy can do to try to correct for this externality. So again, in the case of a positive externality, we have a situation where the marginal social benefit is actually greater than the marginal private benefit. So there are benefits that are accruing externally to people who are not involved directly in this transaction. Things like education and flu shots are classic examples of this. So we have the example of flu shot here. So again, the basic concept is that you benefit by getting a flu shot potentially, but so do other people that are less likely to catch the flu as a result of you being less likely to catch the flu. So we have our market in equilibrium here. That's showing us the private benefit and the private cost, so where our supply and demand intersect. But in this case, since there is an external benefit, the demand curve doesn't represent our marginal social benefit, it only represents the marginal private benefit. So we have a greater marginal social benefit because it's the marginal social is equal to the marginal private plus the marginal external benefit. So we have it where our marginal social benefit is greater than our marginal private benefit. That means that our optimal quantity of flu shots is going to be greater than what the market on its own will provide, because the market will only take into consideration the private costs and benefits. So the market will produce at QE. However, the optimal quantity is going to be where MS equals MB, and I'll put that here. Marginal social benefit equals marginal social cost. Again, as one of our main ideas of this. So we want to somehow produce at point O. Why do we want to do that? Well, before we go over to the next model next to it, it's important to think about what's really happening here. At QE, this is our marginal social cost, red. Our marginal social benefit is up here in green. So what's occurring is at QE, the marginal social benefit of consuming one more unit of this good is greater than the red, the marginal social cost. And that's true all the way along until we reach point O, where marginal social cost intersects with marginal social benefit. So that's where we want to be producing. Now what this is though, this triangle and this whole section, this is going to be our old friend, deadweight loss. This deadweight loss is a little different because this is a deadweight loss as a result of not consuming a good. So these are units of a good that should be consumed that are not. So what can the government do? What policy can be made to encourage these units to actually get rid of the deadweight loss in this instance? Well, we're going to try something called a Pigouvian subsidy. Pigouvian subsidy is where the government is going to, say subsidy in general, is where the government is going to pay money to somebody, either to the producer of flu shots or to buyers of flu shots to make it cheaper. It doesn't matter which one they do. So that's why if you notice here, I did not shift a supply curve or a demand curve. If the government had given the subsidy to the supplier, we'd see the supply curve shift to the right. If they'd given it to the buyers, the demand curve would shift to the right. It doesn't actually matter which one takes place, and so you just follow the instructions on a question and you would shift if they told you to shift. But this is going to show us our end point regardless of whether it was a supply shift or a demand shift, because that does not actually matter. So we had again our initial equilibrium here at point E. We know that this is our optimal amount, so what can the government do to get us to actually consume this optimal quantity at QE or point O? That's where they pay this subsidy. So by giving money to either the producers of or the consumers for or of flu shots, what they're going to be doing is they're going to be raising the price that sellers receive. It'll be PS, price sellers receive, lowering the price that buyers pay, PB. So buyers will pay this quantity out here because again, remember, they're moving us to this quantity. This is our quantity supplied up here. This is our quantity demanded. So in order to get us to get producers to supply this quantity, the price they receive must be that amount where the supply curve intersects with this quantity. To get consumers to be willing to buy this additional quantity of flu shots, the price, since we have a downsloping demand curve, the price must be lower for them to consume this quantity. So we have where the subsidy must be the vertical distance between the seller price and the buyer price. And so you have the idea here that buyers are going to pay a lower price than before. That will encourage them to buy more flu shots. Sellers will receive more money than before. That will encourage them to supply more flu shots. The subsidy is the difference there. The subsidy, by the way, vertical distance is also the same as the vertical distance between the marginal private benefit and the marginal social benefit. So if I were to have drawn these perfectly, the vertical distance between these two should be the same as our vertical distance between our two MSB and our MPB curves. And so this would be an optimal subsidy. Till next time, this has been a The Money production.